Where's the mirror? I mean, this is impossible. Like, this can't be the right interface.
This is actually a bad place for
Okay. Does it work? No, yeah, it doesn't like that. Wait for it. All right. High res. Yeah, high res now. I mean, high res like in 1998 or something. 1280 by 1024. When was that modern? Okay. That's pretty wrong.
Oh, yeah. Read that.
I don't think we're going to get to the 75 on an after lunch session. So no, we're at 18 right now. So I have a giant room and 20 people at the most. Okay. I was thinking maybe it was lunch, but you don't think it's that, right?
I think it's best.
Do we? So how does the, is there a way to interface the design AC? And I plug that in here? Your keyboard cannot be identified. Press the... It wants to identify my keyboard. Yeah. Okay. Hey, if that works. How about that? Yeah, I know. And then apparently no one's going to come. So I'm going to give it a few more minutes just because we do not have a full agenda, and it's maybe 2 more minutes. If you have to be a best, and if anybody needs to go right now, I'll just start. Okay, you want to go first?
Sure.
Okay, well let me do my status and then you can go. So you hang on.
Everyone knows I prepared for ISIS.
Oh, geez. Okay. Is anyone in the room do Jabber? Do they want to do? Does anybody want to do the Jabber scribe? It'd be a first. You'd be the first Jabber scribe. Yeah. Okay, no Jabber scribe again. All right, this is the note well. By participating with the IETF, you agree to the following IETF process and policies. If you're aware that any contribution, something written, said, or discussed in any IETF context is covered by patents or patent applications, you must disclose that fact or not participate in the discussion. You understand that meetings might be recorded or broadcast, audio or video, photographed, and publicly archived. And there's some BCPs you can go look at. I just present what I've given. So here's the agenda. I'm going to cover, I guess, document status. We're a little bashing. We're going to do the beer update next, and then follow the rest of the agenda. Does anyone else want to make changes? Oh, yeah. Well, no, yeah. Let me go through the docs. Okay. Okay. No changes. Moving right along. So this is a document status update. These are the working group docs that are in flight. We've got 2 that have cleared last call. They've been sitting there a while. They're also blocking things, and they will be submitted very soon. They're in Hana's queue. I'll take them over next week if they're not done. IPR polling. So these 2 have write-ups done. The node admin and prefix attributes. As soon as I get the IPR poll done with those, they'll be submitted. And then SBFD has been submitted, and the route preference is working its way through the ISG now. So the other working group docs that we've got 3 updates to the Yang config, to the beer ISIS extensions, which are actually in the beer working group, not an ISIS. And the MRT. And then we have 2 existing non-updated drafts. Les, do you want to talk about for just a minute about the MI? We have some errata on the multi-instance ISIS RFC. And so we're thinking about doing an update.
Yeah, so just RFC 6822, which is the MI, there are a few errata that have been filed. We're going to respond to those. There's also a possibility based on some discussions outside that in the process of doing a BIS to address the errata that we'll consider some extensions that might not be backwards compatible. So I would really like to know who has an MI implementation so we can determine whether we're going to have a negative impact on interoperability. Obviously that'll all get reviewed by the working group if we do make any changes, but it would be really nice to know what kind of impact we're going to have. So if people want to say it in public or in private or on the list, please let me know.
Yeah, but I would prefer public, just because it might affect whether we take on the changes. One of the changes we're looking at is possibly key changes in the MI. I mean, there would be some big changes. So if people are aware of implementations, if they're aware of deployments, this would be useful information for what kind of changes we might take on. So, moving right along. So we've got a few new internet drafts. The ones in bold will be presented today. These are the updated IDs since the last IETF, and again, the bold will be presented today. There was a call by David, I believe on the source desk routing, a call for adoption on the list. I guess it's probably too bad we didn't have a presentation on that. But this is some interesting stuff, discussion. It seems like it's becoming a little bit more solid now. Alia, but you're looking at me strangely.
Sorry, Eliados, I'm not. I think it's a little premature. I think we're starting to have some discussions to understand which of the possible solutions to the general problem. And so I think it's really good to have people look at the source desk routing and understand and think about the implications and so on. It's not clear that it solves all of the problem that is related. That's all.
David Lampeter, if I could respond to Alia, the consensus in V6 Ops is to recommend source test routing to enterprises that have multiple PA prefixes. Are you saying that that V6 Ops is wrong on this too, or is, I don't know?
I would never presume to judge on V6 Ops, and I totally heard the consensus opinion on the email, which was not that routing should then rush and go do source test routing, but rather this is a problem, this is stopping V6 deployment. And I hear that, and V6 Ops are the people who know that. And so I hear loud and clear that message. And I think, and I'm working on learning more and formulating more of an opinion. Source test routing may be part of the solution, but I think we need to understand fully the parameters of the problem. That said, I think it's really valuable on the really please valuable side of things for people in this working group to go off and look at source test routing and to think about the implications of it when it's targeted towards the smaller, larger enterprise that's doing PI addressing.
So can I ask you a question, David, before you leave? This also has a companion draft in the routing working group, is that correct?
Yes.
I would sort of expect the ISIS one to trail that one, if not by a lot, but I mean, so did that already meet? No, that's today, that's after this one, right?
So we have adopted David's draft in routing.
So that was the question. So you have adopted it?
Yes, we have adopted it, and there's enough interest, and there's problem we recognize, so we definitely need to work on it.
Right, so if that's working group item, a document, you can't really do much without the IGPs, right?
You never can do anything.
Right, so that's sort of an interesting question then, right? We have it as the routing working group has adopted it as official work, but they can't do anything with that work without our.
I'm not saying ISIS shouldn't adopt it by any stretch.
Right.
I'm saying that I don't think we have a knee-jerk reaction to adopt it based upon the email from V6 Ops.
Right.
And I also think that until this point and the context in which RTGWG looked at the use cases, which are much narrower and were more bluntly focused on the home as opposed to the smaller, larger enterprise, there's a very different market segment that can come in and care, and that changes some of the context. That's all.
Okay. We can also serve as a break. We can serve as the breaks, right? You know, if you want.
ISIS always serves as the brains.
Oh man. Okay, this has been the most exciting document status I think I've ever delivered. Yeah. So, and I normally flash through this, but we actually have a boldface presented existing ID, which possibly. Oh, and worth mentioning the CARP analysis went to RC. All right, Tony, do you want to go?
presentation, right?
Yes.
So what's that versus where?
Apparently we're not good enough.
Which hypervisor?
Are you supposed to sit in that chair? I don't know.
All right, whoever doesn't see me there. Okay, one view graph, the shortest ever. So we opted the ISIS extensions because in beer architecture, the discussion started whether we will be converting bit string lengths or not when the stuff is forwarded. So I added a sub-TLD where the node can indicate whether it supports bit string length conversions or not, which validates directly the architecture document. But I have the discussion with the architecture people, of which I'm one. So, yeah, right, yeah. And that's about it, yes. The sub-TLD will not be advertised, but the absence now signifies clearly that the node does not support it. Because otherwise later, when they start to realize they may want to support it, it's not clear whether it's an old node or whether it doesn't support it. Okay, that's it.
Thanks, Tony. And Les, I think you're up next with this. Yeah, I switched. Let me get my L2. Hang on one second. L2 bundles, I think, is up. Yeah. Yeah, advertising L2 bundles. Okay. You'll have your slides in momentarily. Oh, this one has the different ending. That's right.
Okay, this is an update on the L2 bundle draft. These are the authors. I'm the second person. Let's see. Okay. Oh, that's bad.
Wow,
Somehow something happened.
Yeah, it's what it looks like on mine.
Okay. Oop.
Maybe it's some kind of.
Is this the?
It's you got some kind of animation thing, I think.
No, I don't have animation.
Yeah, because it's only that slide. Which one would you rather have it overlay?
Is this the PDF or the PowerPoint?
PowerPoint. Do you want me to?
PDF,
Yeah,
the PDF, maybe it's a little bit cleaner.
It's a good thing we got extra time.
Actually, it works. Okay, good. So that's much cleaner. So status, so far we got very minor comments on the draft itself, basically whether we need to make small changes here and there. I think the couple of comments were regarding making references to the IEEE lag standard, which we won't have a problem if you want to incorporate them. The main points of discussion is why do we need that draft, and there were a couple of other alternative proposals. So I've covered the first point, and then I'll go a little bit deeper on the alternative proposals. Why do we need the draft? We already mentioned this in Prague. It's already discussed in the draft itself. So basically, we need to be able to do TE over individual members. We need to be able to steer traffic over individual members. We do not want to suddenly multiply the number of links by 16 or 32 or 64 just because I need to steer. I need to use a few links for traffic engineering, whether few or all of them. And I certainly do not want to force the operator to suddenly change his strategy from bundles to basically he has to assign an IP address or do unnumbered and do all of this. Which is whatever he has, he's going to continue to use, but if he wants to do traffic engineering or steering, then he can still do it. Now, discussion about the alternative proposals. There were 3 alternative proposals. And to be honest, I will go over each one of them quickly, and I'll tell you whether some of them were not very clear to me, but I just listed them here to be objective and to be fair. I mean, people have proposed something, we have to discuss them. So first proposal was the use of BGP LS. That part was not really clear to me, nor to Les. note to anybody. We think that BGPLS is a companion, is a complementary, but not really an alternative. If I'm running ISIS just to do traffic engineering, should I deploy BGPLS everywhere? I mean, it wasn't very clear, but I just put it there. The second option was to, instead of having layer 2 bundles, make everything unnumbered and advertise them as layer 3. The third option was to, that again wasn't very clear to me, but I just copied this from the email. The idea is to have an IP address on the L2 bundle as well as each member. Again, I just put it there, again, to be fair, whoever sent it, basically, I deserve, it's at least an obligation on me to present it. To be objective, actually, I thought I would do some sort of grading that may be slightly subjective. You guys are most welcome to disagree with it, but I listed all proposals starting with the draft and then the 3 other proposals, and I kind of gave grading to each one of them based on what I think is reasonable. So the first factor is scalability. In the current proposal, pretty much there is no scalability. I mean, we're advertising a whole new TLV, and if somebody doesn't understand it, they can just skip it. It does not impact SPF, does not impact anything. It's just one additional TLV. The BGPLS, assuming that I understood what the objective was, would still be the same thing because we will be deploying something new. So the basic ISIS operation is not affected. Having unnumbered interface, we think, is too much because suddenly, instead of having one link between me and my neighbor, suddenly it became 16 or 32. So the SPF of everyone, even an old router that doesn't understand this new TLV, suddenly becomes impacted. The next one, which is having an IP address on the bundle as well as the members, even worse because now I have to deal with the huge number of IP addresses. Suddenly, instead of having an IP address on each side of the bundle, I have 16 or 32. So in addition to having a large number of links, I have even a large number of prefixes. And based on this, I gave kind of this grading. But again, you're most welcome to disagree. Deploy a protocol not deployed before. Of course, I have ISIS. I don't have to deploy anything for all these 3. If I want to deploy BGPLS, then it's something new. So operationally, it's an overhead. Third option, impact on basic routing. This is minimal. I mean, this one is also minimal because for this one, I'm not adding to the link state database anything. It's some new TLVs that is not used in the SPF. In BGPLS, it's a whole new protocol. So again, it has no impact on the SPF itself. This one and this one are very large because suddenly, again, the number of links have been multiplied by 16, 32, 64. This one is even worse because not only the number of links, it's the number of prefixes. This one works for both point-to-point and LAN. Yes, of course. I mean, I'm just advertising a link. This one also, I'm advertising a link. Unnumbered interface on point-to-point, on point-to-multipoint. I don't know how this is done. I mean, I haven't seen it done before. For this one, it is simple. Basically, it can still work for point-to-point or LANs. Using the same protocol for everything, yes on the proposed draft, and yes on the unnumbered, and yes on the numbered. But for the BGPLS, I have to deploy a new one. Exposing L2 info in the L3 protocol, yes, we will be doing here, and that's precisely what we want to do. I mean, this is what we are saying we will do. I will advertise L2 information inside ISIS. For BGPLS, if I understood it correctly, yes, we will be advertising L2 members into BGPLS. How is that going to be done? I frankly don't know. For this one, no. I converted the L2 members into L3. And to be honest, I think this is cheating. I mean, originally they were L2 members. Now I converted them to L3. Well, okay. I just renamed them, but I did the exposition. Protocol change. Yes, I do need to change protocols in the draft that is being proposed, and the BGPLS, because I need to have a new type of TLV. In the other 2 proposals, no, I don't. I mean, we already support unnumbered, and we support numbered links. There is no impact on baseline functionality. Baseline functionality, whether it's routing, whether it's current TE, there is no impact. It's a new TLV. If your router understands it, voila. If your router does not understand it, it's just a block of data. BGPLS, I give it medium because I have to deploy a new protocol. Somebody might say it's not a big deal, that's fine. These two, just suddenly, my link state database again got multiplied by a very large number. So my monitoring tools, if I have SDN controller, my own routing engines will suddenly have to deal with a much larger amount of data. Provisioning overhead, this one is small. You just have to type a configuration on the routers where you want this feature to be enabled. This one is medium because I have to enable BGPLS. I have to basically configure BGPLS on each router. This one is significant. I used to have one bundle with one IP address. Suddenly now I have a lot of unnumbered interfaces that all needs to be unnumbered to something. This one is even worse because in addition to having new links, I need to have new IP addresses. So it's a huge provisioning overhead. Code change, yes, we do need to have code change. I mean, I need to write some code. BGPLS, yes, I need to write some code. This one, no. I mean, everybody supports having parallel links, pretty much. So implementation-wise, if my number of parallel links is 16 or 32, I don't need to modify my ISIS. This one, see, you can look at it in two ways. I have some processes and stuff running on the routing protocol. It can deal with a certain number of prefixes. Suddenly, this number of prefixes got multiplied by 64. Do I need to look at all of them? Probably no. I mean, if I'm BGP, I don't need to look to all of these prefixes. I don't care about them. Do I have to make changes in the code? Probably. At least I need to retest everything. I definitely need to retest everything. I think this is the last slide. This works with RSVP without modification. No, I think we need to make some modification. To be honest, I haven't given much thought about this part, but probably we need to do some RSVP modification. Maybe not. Maybe not. So as the BGPLS, yes, we do need to make some modification. For this one, making unnumbered interfaces has been working with RSVP for years and years. So I am basically having a large number of unnumbered parallel interfaces or parallel links will work with RSVP. This one, as I said, I don't understand it. Maybe yes, maybe no. How do I tell RSVP that this member that has IP address is actually a member of a bundle one? It's like it's a new hierarchy. I am not sure if RSVP supports something like that or not, but most likely we do need to tell RSVP that this interface, this Ethernet 0 interface, it's actually a member of the bundle interface. Hence, if you have some traffic flowing on the bundle, be careful that part of it will actually maybe flowing on this member, even though it appears that it is a different interface. Two-way connectivity. I frankly don't understand how it is applicable here. We don't make two-way connectivity on individual members. It doesn't make sense. But in the draft, we allow any TLV on any sub-TLV of TLV22 to be advertised in this new TLV. So the two-way connectivity TLVs, whatever TLVs, I forgot the number of the sub-TLV number, that is used for two-way connectivity, you can do it here. But does it make sense? To be honest, I'm not sure if it makes sense or not. BGPLS two-way connectivity, I'm not sure also if it makes sense or not. I don't know what does that mean. These two, it is simple. It's basically there are three links that you can do two-way connectivity on, which there is no real issue here. The last thing, you must deconfigure and reconfigure your L2 bundles. If you use the proposed draft and BGPLS, you don't have to touch your configured bundles. If you have to make the layer 2 bundle suddenly break it up into layer 3 interfaces, you do have to deconfigure your bundle interfaces. And pretty much that's it. So I'm giving basically a status update on what we have. We think that basically this solution will deliver what is required, will solve the use case, and will have minimal impact on the current operation of the protocol, as well as even as the future. Pretty much that's it. Thank you very much. Any question? So we are looking to have this adopted. Go ahead, Pushpashish.
This is Pushpashish, Durable Networks. there seems to be in the document no mention about what kind of use case are this going to address.
I'm not sure. Is in the beginning of the document?
So is there, so the next question is, so is there really a need for steering any traffic through a single member link of a bundle?
Yes. Yes, I mean, the simple answer is yes. I'm not sure why everybody thinks that I brought this up we brought this out of the blues and basically we're just trying to basically squeeze it into that. Yes, there is a use case. People want it.
Because I kind of having some personal discussions with some of here, but I didn't hear a real use case other than probing, basically trying to see whether the particular link of a bundle is healthy or not.
Even if that is the case, so what? We still need it.
Well, if that is the only case, we don't need the protocol extensions. We can just do it by another means. We can
So
do it.
like what? How do you look whether you want traffic to flow on this link? How do you do that? But then how do you report this?
That's
the whole point.
No, that's not the control. So any controller who wants really, or a network operating center can actually go and programs labels against that particular link that will take the packet only right across the member link.
Yes.
And because the NOC has actually assigned that label, he can actually build probes using that label from the NOC, right? And then somehow steer the traffic to that node using some other node segment, and then put this label next and exercise that link.
So you're proposing that basically each router has a facility to allow somebody to come and force traffic on a particular link.
That's also a possible solution. Why do we need to actually advertise all this information? I mean, I agree if there is a valid use case where we need a ingress to figure out or compute the label stack for a given path. But if it is only for probing, I don't see a reason as to why you need this.
If there is a need to snake traffic through multiple routers, then this is a must.
Well,
if I want to basically send traffic, snake it through these links this way, and then after that through links this way, then this is the only way to do it.
Yeah, but then is there really need for that kind of?
This is exactly the use case that we got.
So
they want to snake traffic.
Probably what I'm trying to say is that we're probably anticipating more than actually required.
Can I comment on the use case? János Farkas speaking. I also heard about use cases and people are really wanting to control the traffic, which physical link within a aggregated János Farkas. So people really want to control which physical link is used for certain traffic. I'm also aware of use cases.
Yeah, that's what I'm saying. I know that there are use cases. We know actually the operators who want this. So that's the answer. So any other questions? So if the question is nobody wants this, I think you got the response. If you look at the co-authors, there is a response right there. So I'm not sure why people are saying nobody wants it. Okay. Any other question? Okay. Thank you very much.
Okay. I'm sticking with PDF. What's the first? I have you. The BIS. This is up first. Yeah, unfortunately, I don't have that for everyone. We'll see if Les has the strange behavior.
Here we are. Okay, this is, I'm Les Ginsberg, my esteemed co-authors. We have a very minor update to RFC 4971, which is the router capabilities. So here's the TLV242 for router capabilities has a fixed header. The fixed header is as shown here. And note the field in red, which is the router ID, which is 4 octets. That creates a problem when you don't have, you're not supporting IPv4 because you don't have, you may not have an IPv4 address, you may not have IPv4 running on the box at all. So the question is, what do you put in there if you're only running IPv6? This is the new text. Let's look at the 2 pieces that are in the new text. The first part says, okay, if you don't have an IPv4 router ID, then you must put all zeros in the router ID. Then you must use the IPv6 TE router ID sub-TLV, which already exists, it's already been defined, to provide a router ID for the source of this advertisement. If the advertisement, the TLV comes and it has all zeros and it doesn't have the IPv6 TE router ID, then it should be discarded because you don't know where it came from. Today, what are people doing? If they have an IPv6 only box, they can't be sending the router capability TLV because they can't identify the source. They can't fill in a field in that fixed header. So I'm assuming the only thing people can do is they have to provision at least an IPv4 router ID. And remember that unlike in OSPF, you can put your mask on now, the router ID in ISIS must be a reachable address. It's not just a 32-bit number. This is as per the RFCs that define those TLVs. So today, the only choice for people is to actually enable IPv4, at least to a limited extent, find an IPv4 router ID. There was some discussion on the list about backwards compatibility issues. I don't believe there are any backwards compatibility issues. For the boxes today that are quote-unquote IPv6 only and need to send the router capability TLV, they have to be enabling IPv4 to a limited extent, and they can continue to do so. Once they have support through the network for this change to the specification, then they can remove the IPv4 configuration, which was only put in to support advertising this TLV, and they can use the updated behavior. The second clarification we made, there was no discussion in the original RFC as to what value this IPv4 router ID should be. Should it be the same as TLV 134, the TE router ID, or should it be something else? From our standpoint, there's no reason for it to be any other address, so we're just putting clarifying language in here that says if you are putting in an IPv4 router ID, it must be the same as the router ID you advertise in TLV 134.
You mean should?
Yes, should. Thank you. And we'd like to request working group adoption. I would mention, as an aside, there's a sort of a companion draft for the IPv6 TE RFC 5316, which was presented earlier today in TEAS. It has a similar problem because it has a similar format. We're going to bring that draft into ISIS, and it essentially has the same solution. Questions? Okay, next. Okay, this is a new draft, my esteemed co-authors. This is based upon a real-world problem. This problem was actually encountered, and this draft defines a solution to it. The original problem, I believe, was presented at the last IETF. Thanks to Bruno and all the people who presented that and showed exactly what can and actually has happened in a real network. So the problem is that we have a remaining lifetime field in the LSP, so that LSPs, if they're not updated, will eventually age out of your link state database. And because the lifetime gets modified as you flood it, it cannot be included in your cryptographic authentication or your checksum calculation. So the question arises, remaining lifetime happens to get corrupted when it's flooded. This potentially can cause premature aging of the LSP and can cause flooding storms and temporary loss of network connectivity. So this is what the header of an LSP looks like. The portions in green are protected by cryptographic authentication. The key field here that's in red is the remaining lifetime, which is unprotected. The portions that are in blue are protected both by the standard checksum and by cryptographic authentication if you have it enabled. So what happens if the remaining lifetime does get corrupted? There's a number of possibilities here. If the lifetime becomes larger than it was supposed to be, this is a pretty benign issue because the source of the LSP is going to update it before the original lifetime expires, or he's going to purge it if he no longer needs it anymore. So the only consequence of this is if the source of the LSP dies and becomes unreachable, you have an LSP that stays in your link state database longer than necessary, but because you can't reach that source, you don't use it. So it's a benign issue. The real problem is what happens if the lifetime becomes smaller than it's supposed to be. What this means is the LSP will age out on at least some routers in the network prematurely. So instead of waiting for the source of the LSP to refresh it or update it, as the case may be, if he's got changes to the content, somebody else in the network will age it, the lifetime will expire, and he'll purge it. The purge will eventually find its way back to the originator, but in the time that it takes for that to happen, you're going to lose network connectivity. You're obviously going to cause another round of LSP flooding, and this can, if this is persistent, it can create LSP flooding storms. The third possibility is the remaining lifetime becomes zero. This again is if you have cryptographic authentication enabled and you use RFC 6233, which clearly defines what TLVs are allowed in a purge, then an LSP that comes with a zero remaining lifetime, but the body of the LSP has not actually been modified to look like a purge, it will be rejected. So that's, again, not an issue. What are some causes? Well, you could have a hardware failure, you could have bits being flipped, you could have a bug in the software. I think the issue we're more concerned about, we're concerned about all of these, but we're more concerned about the possibility that, you know, something, a layer 2 switch in the middle, if you've got an attacker, has the potential to simply set the lifetime to a fairly small value, doesn't have to have your authentication key, because that field's not protected, and the LSP is accepted, and you get this premature aging and all the consequences of that. So how do we solve this problem? It's a little bit of context here. When a system receives an LSP, it compares it to what exists currently in the database. If the LSP that you receive is newer, then you install it in the database. What's the definition of a newer LSP? You have either it's a brand new LSP, you don't have it in your database at all, or you have a copy of that LSP, but the sequence number that you have in your database is smaller than the sequence number of the LSP you've received, or you have the same sequence number, but the remaining lifetime in the received LSP is 0, indicating that it's a purge. LSPs are normally refreshed by the originator. So in normal operation, we don't expect that an LSP is purged by somebody other than the owner. It can be purged if they believe the lifetime has expired. That's not the normal operation. Again, remember that retaining an LSP in your database longer than necessary is a benign event, takes up a little bit of memory, does not cause any problems in terms of the correctness of your routing calculation. So purging is actually an optimization. You could design a protocol without the ability to purge at all. The only problem you would have is you'd end up with lots of stale LSPs in your database, but your routing calculation would still be correct. So this is the backdrop for the solution. Today, when we receive an LSP, if it's the first time we've received that version of an LSP, we store it in our database. Whatever the remaining lifetime is in the LSP that we received, that's the lifetime we store in our database, and then we start decrementing it as time ticks off. The new behavior is if the remaining lifetime of the new LSP that you receive, and again, emphasis, this is a new copy, not just a copy of something you already have in your database. If the lifetime is less than max age, okay, what is max age? Max age is the locally configured value for the maximum remaining lifetime that you put in an LSP. This is what you put in an LSP when you generate a new version of it. If it's less than that value, then you set it to max age. So if I receive an LSP and it's supposed to have a lifetime of 2,000 seconds, and it comes with a value of 20, or it even comes with a value of 1,000, I set it to 2,000. This is a backwards compatible change, causes no change to the update process that ISIS runs, updating its LSP database. No changes to how LSPs are purged. If the remaining lifetime expires, you purge it. The only change in behavior is that you may retain an LSP in your database longer than necessary. This will only happen in the case where the source of the LSP does not refresh that LSP. Why would he not refresh that LSP? Because he's become unreachable. Either he's crashed or some links have gone down and he is no longer part of your network. If he's not reachable, having these LSPs in your database means they won't be used. So you're not compromising the routing calculation. There's a few deployment considerations. In the base spec for ISIS 10589, max age is an architectural constant of 1,200 seconds. But in practice, most implementations have made it a configurable value. People frequently set this to the maximum. It's a 16-bit number, so 65,000 seconds, which is roughly 18 hours. So it's possible that if you don't configure max age to be a consistent value on every router in your network, that you may get a corrupted remaining lifetime. The originator of the LSP had a lifetime set to 65,000. You have lifetime set to 1,200. You get a corrupted value, which is 500. You set it to 1,200. This is still going to cause the LSP to be aged sooner than the originator wanted it to be. So you may want to set a different number than your locally configured max age for the value that you want to insert in the LSPs that you receive from somebody else. I think this is only necessary if you don't configure a consistent remaining max age on every router in your network. Clearly, it's useful to log cases where you believe you have received a lifetime that is potentially corrupted. You can't know for certain that what you've received is corrupted, but if it's a pretty small value, it's quite likely that it is corrupted, because typically people do not set remaining life or max age to 20 seconds or something like that. So if you're receiving a new copy and it has a pretty small value, it's pretty likely that it has been corrupted. It may also be useful when you show your database, now that you've actually modified the remaining lifetime from what you actually received, you might want to add something in the display that says, well, this is the value I've stored, but this is the value I actually received. That may help you diagnose the problem. And that's it. We'd like to have working group adoption. Any questions?
So I have a question about, do you cover the case of a zero, like a purge?
So the purge?
Yeah, maybe you did. I
did.
What?
If you get a purge, the solution to that is to use cryptographic authentication along with the purge TLV. That's RFC 6233. That means that if it's an attack, the authentication will fail because the attacker is not able to change the contents of the LSP to have only the TLVs that the purge allows. So, well, if you go by the base spec says the content should be empty, but obviously when we added authentication, we had to allow authentication. Then we introduced the purge TLV to say, I'm the guy who originated the purge, to help locate where the purge originated from. I think we also added the ability to have dynamic host name in there as an aid to find out. But there's a very limited set of TLVs that are allowed.
We've had purge creep. Yeah, so can you move forward to a few slides? The thing I latched on was one more.
Which one?
One more. If the remaining lifetime is of the new is less than max age, but non-zero. No, you were in
I was there.
The green line.
Yep.
Yeah. So when but non-zero, right?
Okay.
Yeah.
Hopefully the draft
is
correct. Maybe the slides are not correct.
Right? Because otherwise your purges are not purges.
Yeah. If
that's
the draft,
about a type of corruption.
If the draft does not have that precise language, we can correct it.
Okay.
We're not going to publish my slides, hopefully. But.
Okay. Well, okay. That was my only question, I think.
Okay. Any other questions?
AC Lindum. So the purge, So the purge TLV is covered by the cryptographic cryptographic authentication. How does that help you if you don't include the lifetime as well for a purge?
I can answer that. It's because we only allow certain things in the purge, right? So if there are extra things, it's not a purge.
So you've sent an LSP, an LSP has content. That content does not include. Yeah.
Oh, I see. So you can verify the first TLV, and then you can do a consistency check about the lifetime, which is not included.
Well, not exactly. No, so the purge TLV was defined, I think, about 3-4 years ago. Not everybody supports it, but that's the solution. If you have this problem in your network and you're seeing corrupted remaining lifetime and it turns out to be zero because of whatever reason, the solution already exists. You just have to get your vendor to support it. Yeah.
You can also log. I mean, you could also log the fact that you have content TLVs in a zero, right? I mean, that they shouldn't be there. anyway, this,
I'm not sure which, I mean, implementations today typically have a way of logging, I received a new LSP, if that's what you're talking about. We're also talking here, it's a good idea to log suspicious LSPs.
right. In other words, if you receive an LSP with a 0 remaining lifetime that has content in it, right, a bunch of stuff that it shouldn't have, right, then you have a pretty good idea it's been corrupted to 0.
Right.
Okay, so there's been a working group adoption. One more.
Sorry,
question.
one more comment. In the deployment considerations, you talked about the need for logging, or that it would be desirable. Should you make that a should instead of a may in the draft? I think operators would appreciate that. John Mitchell, Google.
I have no problem doing that. If you could send that comment to the list so I don't forget. He's suggesting, I think the language in the draft just says it may be a good idea to log this, and he's suggesting a should is a bit stronger so that.
Okay, so yeah, there was, I think all 3 of these were requested to be working group documents. So I need to run back through them. The L2 bundles, who has read the L2 bundles draft? Okay, and who thinks it should be a working group document? Okay, that was almost the same hands. Good. So for the okay, so the BIS draft we need to update. Does anyone object to the BIS draft being adopted? Okay, and who has read who thinks the remaining lifetime work is worth taking on? Great. Okay, thank you. AC, you can say that all 3 of those were very supported. Okay, so now we're up to flow spec. But we only have one presentation on flow spec. Right, that was the joke. I kind of fell flat. Yeah, 1 second.
Okay, my name is Genji. I'm going to present ISIS extensions for flow specifications. Next, please.
Oh, I'm sorry. You have this too. Do you want to control? You hit the little. Yeah.
This draft was first presented in IETF Prague meeting. Mainly, we have there are 3 concerns. The first is ISIS is not defined as an IETF PC to CE protocol. So we removed BGP NPL's VPN use cases. Now it only keeps campus network use case. Second, what happens if multiple routers inject a filter component? Actually, this the description has already defined in section 4.1.1. The order of applying the traffic filter rules is the same as defined in IFC 5575. Third, how to limit these flow spec rules in the routing domain? Actually, in the new flow spec reachability TLV, we defined a flag set. If the flag is set, this TLV should be flagged across the entire routing domain. Otherwise, it must not be leaked between levels. So the update compared to the version 1, we removed the section 3.2 BGP NPL's VPN use case. Now we only keep the campus network use case. As we can see from this figure, in the campus network, ISIS is used. So it is expected to extend ISIS to distribute flow spec rows. This is the only use case now in the document. A new ISIS TLV, that is the flow spec reachability TLV defined in the document. It includes type, length, flag, and flow spec entries. A flag is defined as a leaking enable bit. We just explained in the previous slide that if this flag is set, this TLV should be flagged across the entire routing domain. Otherwise, it must not be leaked between levels. And the flow spec entry, each flow spec entry consists of flow spec filters and the corresponding flow spec actions. For the details, you can look into the document. Actually, we have discussion on the mailing list, and this document is actually it is an equivalent draft to the OSPF flow spec. That draft, OSPF flow spec draft, has been a working group since IETF94 meeting, and now the major concern, the use cases, has been updated since the last meeting. So we think maybe this draft can be accepted as a working group doc. You want Mike?
AC, the one difference in the use cases is since ISIS is not a PEC protocol, that use case isn't present in this one.
Yes.
Jean-Marie, I had a similar comment to AC. I was wondering how many actual networks are based on campus, both avoiding the use of BGP for AS interconnection and using ISAS and not OSPF. This seems like rather a carrier-oriented IGP where BGP is commonly used, so flow spec would be BGP based. So I'm wondering about the actual number of relevant networks to this proposal.
Sorry, do you mean that there?
Yes, justifying just the introduction of flow spec in ISAS to duplicate what's being doing in OSPF is not enough for me. Thanks.
I have a similar sentiment. I think what he's saying is, are there any customers who are asking for ISIS for an enterprise network who don't run BGP?
Yeah, yes, we have the requirements from our customers. They already have the ISIS deployed in the campus network.
Okay, and they don't run BGP.
And they don't run BGP.
And they don't run BGP in that same campus network?
I think some customers, they use ISIS.
Okay.
Yeah.
I mean, it would be nice to hear from them, I think, in the list.
Do you understand that the main thing, the main question is that it's hard to believe that there's people using ISIS and not BGP. And if people are using the BGP, that's the better solution for flow spec than ISIS. So I mean, that's the real, I think that's, if you're going to run into any kind of, if you actually have some use cases, some people who come onto the list and say, listen, here's an example where we're running ISIS, we're not running BGP, this is the only way that we can deploy flow spec, and here's our use case. I think that would be very beneficial to the document moving forward. Anybody else? Thank you. AutoConf. Thing.
Good afternoon, everyone. This is Bing Liu. Again, it's the ISS auto configuration. Next, please.
Do you want to show clicker? You're on there.
Around last year, IETF, we received some technical comments and some detailed review, mostly from Les. Thanks, Les, very much. This new version is mainly to capture those comments into the new draft. The most significant technical change is we added a startup mode. When the system ID duplication happens, if the router in the start mode, then it should be the startup mode router to change its system ID. And if the duplicate nodes are both in startup mode, then they follow the normal comparison method. And accordingly, we need to add a startup mode flag in the fingerprint TLV to indicate this router is in startup mode or not. So this new mechanism is to minimize the occurrence of system ID changes for router which is already run in the ISS domain. And we also took into account the duplication between neighbors. The main behavior for the nodes is they must include a fingerprint TLV in hellos. If the duplication detected in hellos, then the node won't form any adjacency. Another one is we remove the clear text password authentication mode. This is originally for distinguish between autoconfig and non-autoconfig, but if we already have the flag, then the startup, especially the startup mode, then it is not needed again. So, but for authentication, we added a usage of the more sophisticated security mechanism, like the HMAC MD5 authentication mode. This is suggested by AC in last IETF. And Les contribute a lot in this new version to improve the quality of the draft. So we added him as a new co-author. Okay, the draft was launched adoption call 1 week ago before this IETF. So if you are in favor of this work, please support in the mailing list. And of course, we also welcome comments. Okay, any question?
AC, I thought this adoption call was before. Is this, it was only a week ago? I don't know that I must have missed it. I thought I supported it once a long time, like a month ago. Maybe I'm wrong.
Well, it seems that I don't recall seeing the adoption call, so. Could we have clarification from the chair?
On when this adoption call was taken, yeah, I thought it cleared adoption already, but. So, well, okay, do you want me to take the slides down and go verify this right this second? Okay, okay.
Use the data tracker.
Hey, we can do that. Is there anything else that we need to do on this draft other than check where it stands? Anybody would like any comments or, okay. So I think David is up next with point to multi-point while we consult the data tracker. Okay, it's not even in.
To check my inbox, you started the call on October 22nd.
October 22nd? Okay.
I think it's still running.
Okay. Okay, now that we've settled that.
Okay. Hi everyone, I'm David. So this is point-to-multipoint again, which we've already presented last time. We're taking on Chris Hobbs as a co-author in the meantime. If you haven't read this before, the idea behind this is simply to allow using point-to-point mode on broadcast circuits with more than one point-to-point adjacency, which essentially moves you naively first to a full mesh, and if you apply policy, it moves you to something less than a full mesh. And we're doing this to minimize the reliance on multicast that we have, and also to allow us to shape the topology that we are presenting in ISIS and put metrics on the particular relation between two participants on that particular broadcast network instead of just between a participant and a pseudonode. So what we presented last time was adding a new PDU type. We did move away from that based on feedback from Les. This is now using the point-to-point hello being multicasted on the network with a down three-way adjacency state. And as a result from that, which is used for discovery, we move to point-to-point TLVs, which are unicast on the layer 2 to the individual participant, and we proceed with the normal P2P state machine on that. And that is already this presentation, so we haven't changed much really. The idea is pretty simple. I'm hoping to get feedback. We're continuing to work on this, looking at interop and appliance, and yeah, we'd be happy to hear your feedback.
Yeah, so I mean, in general, the point is that it was made incredibly simple, right? I mean, we're just reusing point-to-point hellos, and ISIS just kind of works the way we want it to.
Okay, shortest presentation.
Okay. So I guess I have one more comment on that. Since I became co-author, I should make a comment on it. This was originally driven just for the I mean, it was kind of prodded forward by HomeNet, which we may not be a part of anymore, but I think it's still useful work to look at because it does actually, you know, present a couple of nice points, as David said. That got a comment.
Oh yeah, what comment?
I got a comment now.
Oh, you got, just a very minor comment. For those, I mean, this is helping address the case where you've broadcast as Wi-Fi, right?
Right, where multicast is dropped easily.
Right. So in the int area later today, there's going to be discussion about issues with multicast over Wi-Fi. ISIS is not the only affected protocol, and Wi-Fi isn't just used in the home. So from a completely individual perspective, I'm happy to see the protocol expanding.
Cool. So I believe that's the last item. If no one has anything else to add, I think we're wrapped. Thanks. Oh. Did the person that has presented flow spec, did she leave? You said okay, and now I was like, oh, it's good enough for OSD. No, it's not good enough for ISIS. Yeah.